In this case, we need to identify what party. Okay, the problem is this. What is the vapor 40 grams of water at 24 degrees Celsius? If the vapor pressure of your water at this temperature is 23.8 torr. So what's this? It's applicable first. Okay, try to figure out okay. Okay, so the first thing to do is we need to write the data and the given, and then second, we need to identify what is being asked, and third, we need to determine what is the particular topic regarding to this, and then we need to determine what is the appropriate formula and equation to be used in this kind of problem, having that kind of topic for this problem. Okay, because it is very also difficult. It's mixing, right? We don't know really. Okay. Okay. Wow. Wait for a while. Okay. So. Okay. So I need to have it as much paper now. Okay. Wait. Wait. Oh my gosh. Oh my gosh, I'm going copy. Fairness. Oh my God. So our tugnaw oy. I have very strong, a very good air conditioning equipment, AC. Okay. So given, okay, 3.40 grams of sodium chloride. And then 25 degrees Celsius of 23.8 torr. Okay. So as we can remember class, there are lots of unit of pressure. We have the atmosphere, the torr, the bar. Okay, we have also the kilopascal. The Pascal. The Pascal is equal to 1 Newton per square meter. So there's a lot. Okay, and there's also a specific value for standard temperature and pressure. Okay, but in here it's given the problem that there is 23.8 torr in this topic, right? Because physical chemistry, the standard temperature is. So what is the vapor pressure of water? Oh my gosh, above a solution. Actually, the record is very, you have to think, okay? See? Meaning to say, the vapor pressure of water above the solution, meaning to say, this is just equal to the vapor pressure of a solution because the water is in the solution, or it's being mixed in a solution. So if the problem will say, what is the vapor pressure of water above a solution? Meaning to say, vapor pressure of solution also, because they are in equilibrium with each other. Okay? They are not isolated in the mixture. And water means it's in the solution. Okay, of sodium chloride. So we cannot say, right? And then the salt will be dissolved in that. Okay? So okay, non-volatile solute, meaning it lowers down the vapor pressure of solution. Okay, like that. You lower down. So I think this is one example of a collaborative property Okay, and now we connect this to the specific topic of Rial's law. Meaning to say, the lowering of share of a solvent and addition of non-volatile solute. Just take note of non-volatile solute. Okay, because this specific topic will not be affected by addition of volatile solute or volatile solvent. It's always non-volatile. So if we mean about non-volatile, meaning to say not volatile. Okay, so it will still be in the equilibrium with water molecules and the sodium chloride. So basically, this is an electrolytic solution. Okay, because sodium chloride is a salt, it will produce an electrolyte. So actually, what is present here is the ionic bonding. Okay, ionization with salts. Okay, and it will dissolve in the water. So it's being stated in 340 grams of sodium chloride dissolved in 20 grams of water. So there's ionization of sodium salt in this particular solution. Okay, so it is understood to be a strong electrolyte. Okay, meaning to say there's a high degree of ionization. Okay, so meaning to say also that the ions, ions, the positive and negative charges, those are ions, in the electrolytes are completely dissociated into the aqueous solution of sodium chloride and water. Okay, remember aqueous solution meaning there's always a solvent in it called water. Okay, H2O. But if you will never put water, it will never called aqueous. Okay, something like that. Correct me if I'm wrong. Okay, it's gonna be like that. Okay, so the formula to be used is the Rayleigh law. Okay, use Rayleigh's law. It's very clear the representation of non-volatile solute, and it's not been also specified the molar concentration versus the partial pressure. So what's being presented in the problem is vapor pressure, not the partial pressure, because we can use the Henry's law if partial pressure and concentrations are being also presented or given or declared in the problem. So we will use Rayleigh's law, and we cannot also use Dalton's law because it talks about the total partial pressures of one solution. Okay, and then what else? We cannot use the Arrhenius theory for this also. Okay, what else? We cannot use the ideal gas law equation. We cannot use the van der Waals equation. We cannot use the Boyle's law. You know Boyle's law? The Charles law and the Gay-Lussac's law. You can never use that one here. You can never also apply the Le Chatelier's principle for this. Okay. And you can never use also the formula of phase equilibria and solubility product constant. Nor this is not a chemical reaction kinetics problem. Okay. Nor this is not also conduction or electrical conductivity problem, even though there's a salt presented here, because salt is conductive. Okay, it is electrolytic solution. Okay, it will conduct. So it's very clear that this is only Rayleigh's law, and this is not also a Pascal's law. Okay, because there's a salt addition. Okay, this is not also the freezing point of elevation problem, and this is not also boiling point elevation. Okay. So an idea, or we will just solve directly. It's stated that this way: vapor pressure solution. Guys, sorry, Pentelpen is sorry. The green pentalten. I have green pentalten now. Okay, like that. Okay, wait. And mole fraction of water times the vapor pressure of the solvent. Our solvent here is the water. Like this, guys, huh? This is the formula to be used. The vapor pressure of the solution, or equivalent to the vapor pressure of the liquid or the water above the solution, is equal to the mole fraction of the water in a solution. When I say mole fraction of water in a solution, of course, the number of moles of the sodium chloride will be considered, and then times the vapor pressure of the water. Take note in here, guys, that positive and chlorine negative, so there is ionization. Okay, so you remember the formula of mole fraction is moles of solute. Okay, mole fraction of water, or let's say X is an abbreviation of mole fraction. Okay, so let's have abbreviation to make this simplified. So VP, like this, so solution is equals to X, let's say A, we treat water as an A component, times the vapor pressure of the water, which is A component also. Okay, so we simplified now. See, vapor pressure of the solution is equal to the mole fraction of A component, which is the water, times the vapor pressure of A, like that, to make it simplified. Okay, and of course, your component B will be the sodium chloride. But we are not interested for the sodium chloride here. We can only try to have the difference when we get the mole fraction of the water, because it is included. Okay, so mole fraction of water, or A, okay, is equal to, okay, the moles of water, okay, guys, over the moles of solution. Okay. Okay. Mole fraction of A water is equal to the moles of water over the moles of solution, in which the mole of solution will be the moles of water plus the moles of sodium chloride, or shall we say in general form, the moles of the solvent plus the moles of the solute, in which the sodium chloride is our non-volatile solute. Okay, ganon. Okay, so XA, so moles of water, represented moles, guys, remember, is the small letter N. So N A, which is water, is equals to Na plus NB. As I told you a while ago, A component is water, B component is sodium chloride. So it will become now XA, mole fraction of water, is equals to the number of moles of sodium chloride as B. We need to compute that one by one so that we have a mole fraction, because the vapor pressure is already given. So it's very easy to solve, right? The only difficult class is the identification and the way how we distinguish what is the appropriate formula used. Because in science, so many formulas and equations, and then we need to understand and to analyze the applicable similarities could not be denied. Sometimes also it could be mixed, okay, in one problem. But in here, there's no mixing of other equations and formulas to be used. It's just the law of Reals law to be applied. Okay, so like this. So we need to compute the moles of water. Since we know that we have 30 grams of water, Guys, 30 grams of water, how can we determine the number of moles? Always, okay, like this, because it's related to the number of moles. So molar mass, I teach you or I taught you the, okay, the number of moles in the denominator and the mass in the numerator. Okay, so that we can understand. Always in the denominator, so that you can understand really that this is gonna be like molar mass, molar volume, molar density, molar enthalpy, molar entropy, okay, molar force, molar pressure, like this. There's a lot, okay? The term molar volume, the term molar means moles. The moles always in the denominator. Okay, and the second term will be on the numerator. For example, molar volume. Okay, denominator is in the mole denominator, and volume is in the numerator. And there's a lot of units of volume, right? It could be in gallons. Okay, it could be in cubic centimeter. It could be in cubic centimeter. It could be in what else? A lot, right? Cubic feet, right? Okay, gallon is equals to 3.785 liters, okay, based on our stock knowledge, right? And then, what else? 1,000 milliliters is equal to 1 liter, in which it is equal also to 1 cubic decimeter. We can say 0.001 1 cubic decimeter, big centimeter. 1 cubic decimeter, okay, is equals to 1,000 milliliter and 1,000 cubic centimeter. So therefore, 1 cubic decimeter, guys, is equal to 1 liter. Sorry. Okay. Actually, you can convert it also, aside from memorizing, volumetric fluid computation. Something like that. Remember area, gano'n siya. Okay, density times area times the velocity. Okay. But I think density times, if you plug in the units, you can understand really what's really the appropriate, because you can cancel out, and what will remain will be the volume. Okay, because I memorized that, okay, but sometimes you will forget. If you try to multiply those quantities, what will be left? And if you multiply the three quantities, what will cancel out, what the unit left will be also determined through, cancellation. Okay, if your memory is PCQ, that the conversion factor is very helpful, because sometimes you forgot the formula, you can just plug it out. Okay, in the division, the multiplication, and what's being cancelled is automatically that is the formula of the equation, and okay, like that. It's not only, there's other strategy and technique for that if you forgot. Okay, as we do. Okay, the simplification of units. Okay, that's technique and strategy, huh? Okay, don't forget that one. Okay, that's very useful when taking examination. Okay, so now go back to the mole fraction. Some molar mass, I put that here. Actually, we are now the solution proper. Okay, so continuation. Okay, so molar mass is equal to the number of moles of N of water over. Your brains are very quick to analyze if you really understand something like that. So this is the power if you really know what you're doing. Okay, so you need to obtain and determine the number of moles, so that we cross multiplication or just cancellation if you want. Okay, so moles of water is equal to molar mass. Guys, this is basic theory. Molar mass just mass. It's just happened that the molecular weight of a compound is just equal to a single ion. For example, sodium ion, chloride ion, mass, and molecular weight are applicable only if there are more than one element bonded together to produce a compound. The terminology is not technically correct and is not precise to use that one. Just use atomic weight or atomic mass for a single element. Okay? But still apply this one also. Okay? You will see that atomic mass, okay, atomic mass or atomic weight is equals to the mass, for example, ng element, mass of nitrogen over the mole of nitrogen. Because a gas is an element naman siya. Element is metal and non-metals lang siya. Okay, then the gas is a non-metal solid or liquid. So you put atomic mass na or atomic weight. You will say na atomic mass and atomic weight is the number of moles of calcium. But since calcium also is alone, you will never use mole over the atom of calcium. Right? Atom. Single atom of calcium. Because mole only is also good in compound. You understand the point? You will never say also 1 mole of carbon, 1 mole of potassium. Because mole is not applicable to a single element. Guys, if you're taking sciences courses or courses with chemistry or chemical engineering, you should understand the basic foundation. Okay? You will never say there's 1 atom of carbon plus 1 atom of, let's say, magnesium. Because mole is applicable in a compound. 1 mole of sodium carbonate. But you will never say also 1 atom of sodium carbonate. Because sodium carbonate is already a compound composed of sodium and carbonate. You got the point? Okay, that's why I told you here, instead of molar mass, you will use atomic mass kung single element lang siya. Okay, but this is water composed of hydrogen atoms and oxygen atoms. Applicability of the terminology is very important also. In here, our mass of water is 30 grams given in the proverb. Okay, 30 grams of water. Okay, in the numerator. Okay, like that. Okay. Now, the molar mass is equivalent to the molecular weight of water. So, based on my memorization na talaga siya, is 18.016. I don't have to compute one by one because it's already registered in my brain cells. Because water is very common, encountered in our day-to-day life. Okay? We drink water every day. And then, no need to get, what is the molecular weight of hydrogen? What is the molecular weight? What is the atom of? It's automatic. That is 18.016 grams. Okay. But it depends on your course, because if your course is very far from science, of course you don't have to memorize this. Okay, but if your course is related to science, for example, biology, this chemistry, something this physics, or this chemical engineering, or this pharmacy, with sciences, then memorize the basic molecular weight of those substances that are common that we encountered in our daily life. So what is the molecular weight of sugar? Okay, so that is carbon 12 H20O11, that is sucrose. Things like that you need to memorize if you encounter that in your kitchen. Okay, like that. Okay, but then again, it depends on the course. Also for the person, if he really loves to memorize the molecular weight, then it's not an issue. This is an additional information for you. Of sciences, will memorize the basic molecular weight of different substances. So, water, air, sugar, table salt, mga ganun siya, okay? That's very common in the kitchen. In the kitchen, you will always use the salt in your cooking, right? You will always use the sugar when you put sugar in your food or whatever, in your pastries or baking, cake or whatever, Then if you are interested, then memorize the molecular weight of those substances and bingo, okay? You can also compute for the what amount of protein you will achieve, protein, carbohydrates, like that, blah, 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 so on, so that it will give you energy. And you can compute the kilocalories, and ganon. So that's why in your metabolism, you can compute how many calories you'll be, wasted. You're not wasted, being rate. Because excretory system are the system that will responsible in eliminating all the wastes in our body. Could it be liquid waste, solid waste, gaseous waste? We try to eliminate that day by day, so like that. None. So go back to the 8.0 because it's common in the numerator for the 2. Okay, cancel the calculator, please. Charot. Okay, guys, as easy as lower differential equation and advanced engineering mathematics. Okay, like this. Okay, 30 to the problems that are easy to solve or average to solve because they are focused on concentrating on the difficult problem solving, really. Okay, and then they're practicing too much with the complicated problems, and then when the problems present, because I experienced that also. Sometimes you will focus on the most difficult way. It should not be that way pala talaga siya. You should, develop more on the easy problem solving. It's in there, and you can really understand what's going on. Okay? And really the basic concept knowledge how to solve. You understand? Something like that. Because it doesn't matter at all. Okay? It doesn't matter as long you understand the theory behind that and the concept behind that. It's all started really with basic, simple, and easy to solve problems. Okay? So do not take for granted for that also. Okay? That's very clear. Okay. Now, 30 divided by 18.016. Usually in my college days, even though the problems are not very easy, I treat that as difficult. That's why I will become panic like that, and then eventually I will become wrong. Okay, okay. But it could not be that I'm very studious. Okay, for my college days. Okay, studious meaning always studying like this. Okay, so 30. Focus on the acquired knowledge, not on the IQ mental ability. Okay. So more on the acquired intelligence talaga ako, not on the especially in mathematics. So 1.67, or let's just say 1 moles of water. Okay. Now we need also to get the moles of sodium chloride, the moles of salt that will be adding to the solution. Okay, like that. That will be also ionized in the aqueous solution. Okay, so how can we do that? The same story. Okay, look at it. Molar mass of sodium chloride at this time. Okay. Molar mass of salt. Okay. Salt. Okay, we can go directly to number of moles of salt, sodium chloride is equal to the mass of sodium chloride, okay, and the molecular weight of sodium chloride, or the molar mass, sodium chloride, molar mass of sodium chloride. Okay. Now, I still memorize really that atomic mass, even though that was a long time ago, right, 20 years ago, I could still remember 5.45, okay, grams per atom, chlorine. And then for sodium, it's gonna be 23. I don't remember the point something, it's very small value, but it is more or less 23. Okay, so 23 grams per add that one, it will become 23 plus 34.45, something like that. Okay. Okay. 35.45 plus 23 is gonna be 58 something. 58.45 grams per mole is the molecular weight or the molar mass of sodium chloride without looking and handbook or any books or any reference, because that is your stock knowledge, something like that. Okay, and I can start with sodium chloride is equals to 58.45 grams per mole. Actually, more or less 58.45 to 58, like guys, 3 grams, and then divided by the molecular weight in which I memorized. It is 50. So it is 50 guys, like that, hydrogen, what else? those because non-metals will be on the right side. Take a look at the periodic table. As far as I remember, the elements metals will be in the right side and the metals will be in the left. I'm correct? Correct me also if I'm wrong. It was 20 years ago. It is in the left. Okay? And that could be either a lump is the heaviest element in the universe, is belong to the artificially prepared, something like that. Or radioactive materials. Like radioactive substances have high molecular weight. Okay? Like it undergoes very slow. Elements will have a half-life value. The time it takes for to be decomposed to active substances. Okay, like that. All elements will have a half-life. Okay, like this. So 3.40 divided by 58.45. 58.45. Position ng more calculates akong brain cells. Okay, correct me if I'm wrong. Okay, 0.058. Okay, 0.58 moles. 0.058 moles of sodium chloride. Now, guys, is this the number of moles we need to use? Take note. The sodium chloride is having a salt property, that is electrolyte, guys. When you add water, it will be ionized. It's not the same as the sugar that we take in every day, we put in our coffee. That is not a salt. Okay, there's no ionization, there's no degree of ionization because of sugar. Okay, so salt is different. Okay, it has a high degree of ionization. So meaning to say, it will ionize. There's an ionic bonding. Okay, sodium plus and chloride mole fraction. This is only our basis of calculation so that we can produce the, because the sodium chloride will ionize, and it will produce sodium positive plus chloride negative. Unlike the sugar, it will never break down in the solution that will have charges each individually. It's not like that, the sugar. The sugar is just like sugar, and then if we will add the water, it will become hydrated only, and you have to put point times water on the other side. Okay, or it could be OH on the double replacement displacement type of chemical reaction. It's different, right? There are 5 types of chemical reactions involved in chemistry. So those chemical reactions will fall in each type of chemical reaction, or else it will deviate the theories and concept if those chemical reactions will not fall on the certain types of chemical reaction. So this sodium chloride is a special type of chemical reaction, electrolytic chemical reaction, involves electrolytes or salts. So there is ionization chemical reaction. So there is ionic bonding. Okay, ionic meaning ions, positively charged ion and negatively charged ion. So the negative will be the electron, the positive will be the proton. That's why there's a interaction of its charges, or there's a strong polarization reaction. That's why we have polarity. Okay, so polarity is a characteristic in order we can produce electricity. Okay, you got the point? Polarity, something like that. Oh my gosh. Okay, why? Remember, there's a covalent bonding, right? There's a non-polar covalent bonding and polar covalent bonding. Okay, now, if it is equally shared, guys, that is a non-polar covalent bonding. If there is an excess electrons or lone pair of electrons that is not completely shared, then that is polar covalent bonding. So polar, the word polar, okay, that's happening with sodium chloride. Okay, because that's equal all the time. If you are, there's a water, there's a sodium, don't you think that they will be equalized in distributing or transferring the electrons? It's not. Okay, there will be a strong pooling of electrons in the part of the chlorine. There's also a weak pooling of electrons in the part of sodium. Something, and the water part, oxygen also will pool electrons, something like that. And then, let's say the hydrogen also will, example only, I'm not really specifying which among them will pool, will push the electrons, will transfer. I'm telling only generally that most of these atoms will have the characteristic of pulling electrons, pushing electrons, transferring the electrons, or moving away the electrons, and not completely shared. That's why it is polar. Okay? This is an excess. And now we understand what is polar all about, right? It's not equal. It's not completely shared. So there's an excess or lone pair of electrons, could either be the hydrogen, the oxygen, the sodium, and the chlorine or the chloride, because this is in this problem. Okay? So above the solution of sodium chloride, and there's water. So of course, hydrogen, oxygen, sodium, and chloride. Okay? So that's gonna be like that. So there's an equal sharing of electrons. At the same time also, a unit bonding is there. Wow! Multiple bonding pala siya talaga. Okay? So responsible polarity, something like that. Okay? Now, 0.05 is not enough, guys. Okay, this is very tempting to most of the students because you will end up use these moles of sodium chloride as your moles, but it is not, guys, because it will ionize in water. So we will still have 0.058 moles of sodium chloride. You get the point? Again, then it will react to 1 mole of sodium chloride, the denominator 2 particles of sodium plus chloride. Because in the ionization process, it will produce sodium positive and chloride negative. They will separate as a particle. Okay, not as a compound. So be careful in this problem also, huh? So usually the board examination will be like this because it is it needs analysis. Okay, it needs analysis because most of the problems, to tell you honestly, will never having this because most of the compound will be given in this kind of problem also are not electrolytes. Okay, just like sugar, carbohydrates, protein, an ionization property, something like that. So normally the number of both. Okay, so we need to determine the number of particles it will produce during the ionization reaction in the aqueous solution. Okay, I will put in the papers so that we can really picture out, right? Okay, this is a sodium chloride that will go in the water, something like that. Sodium chloride. Okay, sodium chloride. Put AQ in the subscript of a water molecule. So AQ. Okay, sodium chloride is S because that is solid originally, or solute, that non-polar. Okay, like that, non-polar solute or non-volatile. So we can say talaga most of the equation is like this. So it is you can determine the charges. You can easily think, negative charges, positive charges, like that. Okay. Okay. Now, so this is sodium chloride plus water, and this is one solution, aqueous solution. So this is double displacement. I show you the chemical reaction so that we can understand that there are 2 particles will be produced in the ionization chemical reaction. Okay, this is sodium chloride, like this. So this is reaction because you add water. Okay, in hydrolysis reaction, basic knowledge, guys. In hydrolysis reaction, when you're adding of water, you will produce an acid and a base automatically by theory. Okay, so you will produce a hydrochloric acid, okay, which is a liquid, plus the sodium hydroxide, which is a base. So meaning to say, guys, in this manner, sodium hydroxide is also liquid, right? Like that. And this hydrochloric acid, strong acid. And this sodium hydroxide is a strong base from sodium chloride plus water. So hydrolysis reaction. Okay? Hydrolysis reaction. So you will balance now the chemical reaction, something like that. We are not after of the balancing of the equation. We are after to the particles it produced. So like this. So take note. Okay? HCl. So the chloride here is negative. This is the particle what we mean. if we will tolerate the chloride, because this is the chloride that is being added to the water to produce as HCl. It's not our concern man ang compound, ang particle man siya. Okay? So chloride. And then plus the sodium positive also in the sodium hydroxide. So there are two particles, sodium positive and chloride negative. That's taking place in HCl, the chloride, and taking place also in sodium hydroxide, the sodium ion, okay, from the hydrolysis reaction of sodium chloride plus water. Okay. The problem did not specify this because this is not the concern of the problem. Okay, it's not being asked the chemical reaction. Okay, nor the charges is not being asked. But what's being asked is the total moles of solution. And then the moles of sodium chloride here is undergoing one ionization. We need to determine the particles. So our formula now here, we obtain already the 0.58 moles of sodium chloride, in which we will not substitute that directly to the mole fraction formula. Be careful. Okay, so 0.58 moles of sodium chloride. Okay, sodium chloride times stoichiometric relationship. How many sodium chloride in this chemical reaction? 1 mole. Oh, ganon. So 1 mole of sodium chloride. Nag-ano pa rin tayo, nag-CHE calculation, but the basic stoichiometry or the basic chemical engineering calculation, CHE calculation. Okay, in HCl, then the numerator will be 1 mole of chloride, 1 particle of chloride plus 1 particle of OH, that is 2 particles, the numerator, 2 particles. Okay, so divide this one, times ni siya, ilangan siya. Okay, 2 particles times 0.1 mole of NaCl, mo ni siya inyong. This is the mole particles you will be able to substitute in the mole fraction of the water, because you need that to solve for the equation, the moles of solute. Okay, the moles of sodium chloride in terms of ionization reaction. Okay, 2 times 0.058 is equals to 0.116. Bongga. So 0.116. So this is now called mole particles. Okay? Mole particles ano siya ha? This is not solely moles because you multiply it with particles. When you cancel that units here like this. See? Okay? Okay guys? 0.058 moles of sodium chloride. Then multiply it with in every 1 mole of sodium chloride there will be 2 particles produced, the sodium ion and chloride ion. So we have 0.116 mole particles. So this is we will be using now 0.116 mole particles and the 1.665 moles of water. Now substitute now in our equation, in our introductory part, which is that. Okay, which is introductory part. Nalagput, charot. Okay, so this one. Okay, the vapor pressure of water above the solution is equal to the mole fraction of water the vapor pressure of water. So we can solve now by direct substitution now. Okay, so let's prove the theory that the vapor pressure of solution will decrease if you add a non-volatile solute, which is known as the sodium chloride or the table salt in our kitchen. Okay, something like that. Okay. It's very cold, guys. I have to off the AC. Gosh. Sorry for that. Gosh. It's very cold. I cannot breathe properly. Charot. Okay, sorry for that. It's very cold. Okay. So, go back now to business. We have now the vapor pressure of the solution is expected to be reduced, because by theory, it should be reduced upon the addition of a non-volatile solute called the sodium chloride. Actually, there's a lot of non-volatile solute chemicals, okay? But in this problem, it's mentioned sodium chloride, okay? So vapor pressure of the solution or vapor pressure of water above the solution, like that, or equal also to vapor pressure of solution because it is in equilibrium with each other. Okay, do not forget the principle of equilibrium. Okay, to simplify things out in chemistry or higher chemistry, something like that. So mole fraction of water, sorry, mole fraction of water, which is XA, right? We simplified that already. Then vapor pressure of component A. Okay, our component A is water man talaga siya. Na-substitute na. Okay, XA, which is mole fraction of water. So moles of water, in which we computed already, equal to 1.665 moles water is in here. Right? It's very clear, class. Okay, substitute. Ganun. Closed and open parentheses will be involved if there are a lot of quantities to be substituted, okay, to be incorporated like that, or to be involved. So that's the purpose of closed and open parentheses or the bracket. That's why we have PM-DAS rule in algebra. Meaning parentheses, multiplication, division, addition, subtraction. Means there is it's not really subtraction, addition, and secondly the exponential, third division, fourth addition, and last is subtraction. Okay, so you should apply that in computation in mathematical operation. It's also a very so mole of water will be 1.6 plus mole, as I discussed our chemical reaction. So we obtained 0.166 mole particles, so plus 0.166. Okay. Also write okay, something like it's a 0.116. You should be extra careful for this because these are numbers. Okay, like this. Okay. And then the vapor pressure of component water is mentioned also in the problem during the introductory part of this. Convert this to mmHg, psi, bar. Okay, you should analyze if the choices in the problem and the question is like that, then you don't have to convert, of course, common sense. Okay, so your time. Okay, but if the choices really is that already, then don't convert. Okay, something that we see every day in our daily life. Okay, so if somebody will ask you, Dad, what is the vapor pressure of water? Then can I say automatically, become shock knowledge scientifically. If somebody, because 25 degrees Celsius is a standard temperature. Density of air, which is 1.29, like that, okay, kilogram per cubic meter. You cannot memorize and derive that one through ideal gas equation. Percent and looking the book. Okay, so you will have the knowledge that 1 mole of an ideal air, which is also the number of moles, the universal gas constant times the capital. Thank you. Something like that, okay? So the vapor pressure of water is 23.84. Okay? Okay, sa language siya, guys. Focus lang din sa mga basic language siya. Density of water, like that. Mga basic language. Water, mga pinaka-basic siya. Exists in 3 phases. Solid, liquid, and gas. Solid when it will become ice. Okay? Gas properties of water without looking the book. Okay? If your course is a science-related course, okay? No problem with other courses like College of Arts and Sciences because memorize, especially the specific capacity of water at standard temperature. Okay, it's always like declaration. Okay, 23.8 ganun siya. That's the case. Okay, 1.665 plus, and there also, so 1.781. Okay, memory in or memory recall. Ganon. Okay, so 1.668 memory recall, diba? Use that one also so that it will be easier to remember, right? Okay, ganon. So, okay, times 3.8 is equals to like this. So, let's prove ha. Okay, 1.665, 1.781 is equals to times 23.8 is equals to 22.2. Wow, let's say the, actually I get the answer but I don't look the solution. Okay, that's my normal culture since I was in college really. I solve first rather than looking the solution. and it will really helps a lot in facing examination because it masters your brain cells to capture the analysis like this and mathematical comprehension in relation to the science theories concepts. Okay, solve first and then look the answer and the solution so that you can really evaluate your performance, how you solve science problems. Okay, so that is also one of my technique and strategy and hint for you guys. Okay, tips. Okay, especially if you're taking engineering courses, solve first before, if you have an answer, then compare to the solution. You absorb that in your brain cells. By the time a problem will be like that also in appearance, or you can really, and do not focus on the difficult problems really, okay? Because most of the problems will be get are from easy, average, high average, and a little bit difficult, and only few difficult problems will come out. Really, it's only our mentality that takes us in the higher perspective, because it's very difficult, but actually it's not really that difficult at all. A little bit difficult lang siya, but really that super difficult. Okay, the what do you call that, our mental state of mind, because we label that already as difficult, in which in the first place it's not really that difficult. Okay, so the mentality also matters in facing examination. Mentality, the way you how psychologize things matters a lot, because it is the brain will help you to think, to analyze the problem. It is not the heart. Remember that it's not the emotion, it's not the heart that will solve the problem and question. It's your brain cells, mental state of mind. So the way how you psychologize things, make it one hand and one tips, sorry, singular form. English, oh my gosh, oh my goodness. English, oh my gosh, oh my goodness. Okay, sir, I will discuss that. Theory. Okay, I get 22.25 okay, but it starts already. If we have form of solution, okay, that is directly proportional with each other. If you decrease the vapor pressure of water, you also decrease the vapor pressure of the solution. Something like that. Try to have a mathematical observation. Let's prove. Okay, PA is equals to vapor pressure of solution. Let's prove why. Okay, so meaning to say the vapor pressure of the solution has been lowered and reduced to 25% of a non-volatile solution, then it will not be reduced. If you add a volatile, okay, something like that, because volatile, non-volatile solute has to do the property of diffusion, okay, or evaporation. Substances that is the sphere. Okay, so atmosphere meaning the vapor, right? Like that. So if you add a volatile solute, it has a high molecular weight. It's very adequate for thorough wastes. The matter of waste, like that. Or an E. coli. Not the vapor pressure of the solutions. Or if we decrease the vapor pressure, dependent with each other. Examination. Here, so there are two that is less than 20. So, ang labad mo sa ulo, duha na lang. So, vapor pressure of the solution will always be lower upon the addition of non-volatile solute. So, you save your time. If you know the theory. Even, there's a mole fraction, there's a pressure, there's a volume, and then it will not matter all because the theory says the vapor pressure solution will always be lower if you are non-volatile solute. So you save time in your computation. Go to that and memorize the basic theories and concepts, because sometimes the concept, and there's only one like this, is less than 23.8, then bingo, wow, mental ability na talaga siya. Because the instructors, the professors or tutors are only guide, cannot spoon feed you everything, and they can teach you everything, how to solve that systematically, in a perfect library and solve by your own. Okay, because they are paid by the school, university and institution, but the 100% is in you. okay, is okay, aside from your instructors and professors, you have to do by your own, okay, without them, something like that. And go to the problems also that is not commonly discussed by your instructors and professors, because normally they will discuss the most basic and the most gas, will put that in the prelim exams, and then they presented in their discussion. The purpose there is very easy. They let them think, they let them you to think out from the box during the discussion, okay? Because it's not limited only to the particular. That's why I'm telling you, you have to connect to the data and recall the stock knowledge, like that, blah, 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 so, and link the appropriate form. Important, really, in passing certain examinations. Sa high school pa lang, sa elementary, gi-memorize na memo na. Okay, density, volume, mass, chemical reaction, different laws, different scientists' contribution. Memorize that completely in your elementary, in your high school. Then in college, there will be no problem. Really, trust me. Okay, that's my true confession in passing. So there's a lot of additional, but still the basics are there in the high school and elementary level. Okay. Water is being discussed in elementary, okay? That it is a liquid, okay? Like that, that it will occupy in the shape of the container. Oh, ganon. Solid, liquid, gas, matter. Oh, matter, anything that occupies space and has mass. Elementary, parang gi-memorize ang mga definition sa matter. So that in college, you will found difficulty na already. Okay, what are the three states of matter? Like that's being discussed also in grade 6 or in grade 5. Something like that. So discussed in elementary. Okay, Antoine Lavoisier is the father of modern chemistry. And you wait for college just to know that. So what's that? Learn that from the lower level of education rather than the higher education. That will be introduced there. Calculus, advanced engineering mathematics, like this. Bang. If you are just dependent in your college knowledge and information, hindi siya matabang talaga, especially if your course is very difficult. Okay? You will rely talaga stock knowledge. Okay? Especially the conversion guys. Okay? This is not to be arrogant, guys. I meter, the feet, the mile. I did not. That's why in college, it's easy for me to convert already because I memorized that in my brain cells. Okay, remember? 1 feet, how many meters? Centimeter, how many inches? 1 mile, how many feet? 1 nautical miles, how many like this? Because it's also discussed in a lower level of education. You will rely that in the college na makuha. Okay? Kaya balik-balikod naman na siya. Especially acceleration to gravity. Okay, the 9.81 meters per second squared, the 32.2 feet per second. It will be used over and over again in the college. And then high school, also third year high school, chemistry is there. The balancing of equations also discussed that. Usually guys, in a stoichiometric calculation, always like that, atoms and moles relationship. Okay, you compute that through the given chemical reaction, balance chemical reaction, and the others will follow. The pressure, the volume, the number of moles. Okay, but the addition will be difficult in the higher levels of sa may mga chemical engineering or whatever in your college, there's no problem. Okay, memorize everything. Sound, acoustic, geothermal, energy, okay, manggamit siya chuba-chucho. Okay, like that. What else? The basic of distance, speed, velocity, motion. So Isaac Newton, the law of interaction, the law of inertia. Okay, the first law of Isaac Newton is the law of inertia, right? And then it is whenever a force is applied to a certain object, it will resist the motion and produce its own inertia, something like that. Okay. So force is acted on the object, so there's an inertia, something like that. So first law siya ni Isaac Newton. Maganda no, just understand and memorize that one, okay? Like that. Okay, this direct relationship, okay na siya. So our answer is perfectly correct. 22.24 na talaga siya, TORR. Okay? So before I end this vlogging, so again, okay, if you have a blank sheet of paper, put in your blank sheet of paper now. So standard pressure values, okay? mmHg 760, okay. Torr 760 torr. PSI 14.7 pound per square inch, okay. Pascal 101,325 Pascal or 101,325 Newton per square meter. or 101.325 kilopascal standard pressure in terms of bar. Up to 1 because 1.013 is very near to 1. Okay, but technically the specific amount or the value for that bar is 1.01 bar, 27 pounds per square equals to 100.135 Newton per square meter is equals to 101,325 Newton per square meter. Okay? Like that. Organic liquids like that at certain temperature. Mag-usap-usap ang temperature good. Okay? What I memorized is only at 25 degrees Celsius. Engineer's handbook or the Fred Moore, the orange chemistry book. And the physics book also in the last part. Physics books have also values of vapor pressure of organic and organic liquid and pure substances. Okay, refer that also. There's also in the online, the website. Okay, in the Wikipedia have also, or any online sources have. Okay, like that. But the problem is if you don't have data also. When you go there and somebody will ask you, oh, Sir Sotero, what is the vapor? Okay, then simply memorize the value at 25 degrees Celsius. Okay. You got the point? It's not, meaning it's not obligatory, it's not mandatory to memorize, but it's an advantage to memorize because those are common like that. Okay? So, very clear na talaga ha, that's Rio's law in physical chemistry and real lecture. That's why general chemistry lecture is prerequisite subject before taking up physical chemistry, organic chemistry, quantitative chemistry, qualitative chemistry, biochemistry, biochemical engineering, and physics. Okay, prerequisite siya. Okay, now, if you are taking chemical engineering, it's also a prerequisite in unit operation subjects and unit processes subjects. And of course, especially the chemical reaction kinetics or chemical reaction engineering, which is the heart of chemical engineering. Sometimes also a question like that, which subject is the heart of chemical engineering? Kasi kasi, or the main or the center of the study and the focus of chemical engineering, your answer will be chemical reaction portion. Just like a cement industry, the heart of a cement plant or in heart talaga in a cement plant production. Just like that. In chemical engineering, okay, and the chemical engineering, the contribution to science. Okay, guys, it's very clear. Thank you much for this lab. If you want to subscribe, you want. If you really like also, if you like the notification bell for